So suppose we'd like to evaluate the limit as x approaches c of the absolute value of x minus c divided by x minus c. So anytime we're asked to compute a limit, what we're really after is, understanding the behavior of a function as x gets close to something. In this case, we want to understand the behavior of this function right here as x gets close to c. So there are a variety of different ways we can do this, as you guys have seen. We can compute limits by graphing the function and just looking at what happens. We can compute limits by making a table of functional values and seeing if we can find a pattern for what the function does. We can compute limits by trying to do some sort of algebraic trick on the function to get a cancellation, because you notice that we can't evaluate this function at x equal to c. It's not defined there. We get 0 over 0, and that actually doesn't tell us anything. It doesn't say that it blows up. It doesn't say the limit doesn't exist. It just says that we have some more work to do before we can understand what's going on. So one way to understand what's going on with this function is to sort of look at it and see if you notice anything sort of odd. We have an absolute value, so that means that we can't cancel right away. But what we should look for is a similarity between the numerator and the denominator. So we want to sort of answer the following question. How is the numerator, how is the absolute value of x minus c related to the denominator, which is x minus c? How are those things related to each other? And that'll sort of help us understand the function a little bit better, I think. Well, you know some things about absolute value, right? You know that absolute value makes things positive, right? Well, what does that mean, it makes things positive? Well, if the thing you start with is positive and you take an absolute value, then the output isn't changed from the input. So sometimes it's equal to x minus c, right? And this is when the input, when the x minus c is positive. Sometimes you take absolute value and the sign changes, right? If you take the absolute value of -5, you get +5, which is really the negative of what you put in, right? So if your input is negative to begin with, if your x minus c is negative to begin with and you take the absolute value, the function is going to change the sign of it, right? So those are the two possibilities for what the absolute value of x minus c can be. So let's look at this and see if we notice what happens to this function now based on our definition of absolute value. Notice that if I divide absolute value by x minus c, then in this top case, I'm really dividing x minus c by x minus c, so I really get 1. And in the bottom case, I'm dividing the negative of x minus c by x minus c, so I get -1. So I can just write that down as a functional definition. So the absolute value of x minus c divided by x minus c is going to take on two different values. One of them is +1, and one is -1. And when do those occur? Well, this is going to occur for values of x minus c strictly greater than 0, because I can't divide by x minus c if x minus c is equal to 0. So this is going to be if x is strictly greater than c, and this bottom one occurs if x is strictly less than c. So at this point, we're in a position to graph our function. We can graph this function that we're looking for the behavior of because we have a piecewise definition of it, and we know that it breaks up around x equal to c. We don't know what c is, so we're free to sort of just put it anywhere. I guess we can just assume it's negative because why not, right? Well, our function takes on only two values, +1 and -1, so let's put those on our graph, positive and -1. And we know that for all values of x that are bigger than c, our function is just equal to +1, right? So let's go ahead and graph that here. +1 for x values bigger than c, and it's equal to -1 for x values less than c. Notice I have to put open circles there because the function is actually not defined at x equal to c at all. So now we are in a position where we can compute a limit because we have a graph that we can look at. And notice that we need to compute this limit from the right and from the left because we're going to have different behavior coming from either direction. So the limit as x approaches c from the right of this absolute value function divided by function itself, this is going to be equal to what? Well, as x approaches c from the right, it's coming along the x-axis this way. So this is the function that we're looking at, and you can see that that limit is just equal to positive 1. On the other hand, if we look at the limit as x approaches c from the left of the same function, well, now x is coming along the x-axis from the left, approaching c, and we see that this function is the one in question. And you can see that that limit is just equal to negative 1. Now notice that our right-handed limit is different than our left-handed limit. And what does that say about our overall limit that we were asked to compute, right? This limit is only defined if the right and left-handed limits are the same, if they're equal. So we can say with all certainty that the limit as x approaches c of this absolute value function divided by the function does not exist. So we haven't found the limit, but we have shown that it does not exist.